Alrighty, here we go. We are moving on into Module 6 now that we've done some review and practice with some of our algebraic manipulation and operations. Now we're going to dive into Mod 6. So I need you to grab your notes. And we can add in this textbook pages for this particular section of Mod 6 are 173 to 179. We'll do some book work. We're also going to do some practice in ScootPad. So our essential question today, which also ties in to being exactly our learning target, just written as a question, is how do I add, subtract, multiply, and factor? Notice I didn't say divide, but in a way, it's kind of like we're going to break it apart, which means in a sense, we're kind of like dividing, but we're going to call it factoring, kind of like when you made factor trees. Algebraic expressions. All right, so here we go. Do you remember distributive property? We've been practicing this a little bit. The distributive property basically is taking something that's written as a product. I'm going to write down right underneath here, product. And I want you to put this example down, 5, and then the quantity 2x plus 8. In between here, it implies multiplication. So that's why we call it a product. And to simplify this, because I can't take 2x and 8 and combine those two terms together because they're not alike, I have to distribute the 5 by taking 5 times the 2x, that will give me 10x, and then take 5 times this positive 8, which will give me positive 40. 10x plus 40. I can't combine those two together because this has an x, this is just a constant, they're not like terms. So the distributive property is kind of like taking this product and multiplying it through and getting a new expression without the parentheses anymore. Factoring is kind of basically undoing a distributive property. Your book will define it this way. You're writing something as a product, but basically it's kind of like undoing distributive property. And here's what I mean by this, okay? Do you remember back when you started working with prime numbers and you were breaking a number like, let's say 6 down, and you broke it into 2 times 3? And then that's as far as you could go in breaking these down into prime numbers. So you said, all right, I've factored it. 6 equals 2 times 3. Well, now we're going to take it one step further, and we're going to do it with an algebraic expression like this. Let's say I had something like 6x plus 14. Okay, now right now I can't combine those two together, so it's just sitting there, two different terms, 6x and 14. But I could factor it if I said, what does 6 have in common with 14? Can you think of a common factor? You'd say, well, they're both even, so I could factor a 2 out of each of those. That would leave me a 3x here and a 7 there. So what we do is we have to use parentheses to say, if I take a 2 out, I'm left with a 3x plus 7. If I redistribute it, I get 6x plus 14. So factoring is breaking things apart into a product, and when we have an algebraic expression, we're looking to see what they have in common. Okay, so let's give some of this a whirl. Okay, first they're going to ask us to just do some adding and subtracting, which basically means combining like terms. All right, Jill and Kyle get paid for a project. Jill is paid a project fee of $25 plus $10 per hour. So let's do this. I've got Jill here, and she gets 25 bucks plus $10 times every hour she works. Aha, we need a variable to represent hours because we don't know right now how many hours she works. So I'm going to say, let H represent hours. Okay, so here's Jill. $25 plus $10 times H, the hours. Now, Kyle here gets a different fee structure or pay. He gets $18 plus he's going to get $14 times every hour. Aha! Those are different. Now, write an expression to represent how much a company will pay to hire both of them to work the same number of hours on a project. So, Jill gets this much, 25 plus 10 times H. Kyle gets this much. So basically, we need to add all of this together. All right. Now, sometimes people might put parentheses around these to just kind of say, ooh, here's Jill. Ooh, here's Kyle. However, I don't, like up above, I don't have anything to distribute. There's no additional number outside of these to multiply through. So in a sense, I really don't need any parentheses. I have 25, I have a plus 10H, I have an 18, and I have a 14H. Seems to me what I need to do here is look for terms that are alike and get them together nearby so that you can combine them. Well, I see 25 and 18. Since this is all addition, I'm basically using the commutative property to say, hey, I'm going to switcheroo the order of these two guys, and then I'm going to use the associative property for addition that says I can group things to combine them. This gives me 43 as a constant or a number. This would give me 24H. And really, that's as far as I can go. I cannot add the 43 and 24 because they are not like terms, just a constant. This is an algebraic expression. Okay? All right, let's take a look at something else here. Do some simplifying. All right, so this is a product, 7 times this whole quantity. So to simplify this, use the distributive property. 7 times 9 is 63. Okay, 7 times that 6m, and it's positive, is 42m. Because these are different variables, I cannot combine them together. You're done. Ooh, decimals. Here we go. 2/10 times 3b. Multiply the numbers together, 2/10 and 3. That gives me 6/10 times b. And then think of this as negative 15. 2/10 times negative 15 is negative 3. I got to erase that here. This is what happens when you try to do too much in your head. Do-do-do. Do-do-do-do. 3 or 3.0. C. Different variables, cannot combine them together. Let it be. All right, this one we have 3 terms to distribute 2/3. So take 2/3 times 6e. Let's see, that would give me 12/3 times e, which is 4e. Then take 2/3 times 9f. That would give me 18/3 f. That simplifies to a 6. And then this is negative 21 times 2/3. Negative 42/3. That's negative 14g. Okay, cool. All of these variables are different, cannot combine them. All right, now let's practice some factoring. Factoring is going the other way from the distributive property. Okay, so look at this one first. 4x plus 8. You want to break this into 2 things being multiplied together. So you're saying, all right, what does, since this has an x and this one doesn't, I have to focus in on the numbers. What do 4 and 8 have in common? Well, they have a common factor of 2 or 4. So if I factor a 4 from that 4x, it's kind of like dividing it out or breaking it apart. That would give me 1x, 4, and 1x, 4x, plus 4 times what number here would give you 8? That has to be a 2. Double check it. When you redistribute, do you get 4x? plus 8. All right, let's take and give these ones a challenge. 2x plus 2. You have a common factor of 2. What is left on the inside? I would have a 1x. Now, if you just want to write x there, that's fine. And a 1. Double check by distributing again. There you go. 3 and 9, what do they have in common? They have a common factor of 3. When you factor that out of 3x, you're left with 1x. When you factor a 3 away from the 9, you have 3. Double check by distributing. 5 and 15 share a common factor of 5. And when I factor that out, I'm left with a 1x and 3. Take a look at the next one. 4 and 16 share a factor of 4. That would leave me with a 1x and a 4. Ta-da! All right, let's take a peek here with what we have next. Ta-da! I'm not going to do those. I would like you now, as we've gotten through those examples, I want you to start taking a look at page 176. Check on Schoology to see what exactly your assignment is going to be today. And as always, good luck and may the force be with you.